Okay, in this video we're going to be looking at cosine law and the sine law, and also ambiguous cases involving the sine law. So first of all, this is our sine law here. Basically, it's a ratio of sine values and side lengths to angles. So, for example, theta c over c is equal to sine theta a over a, and we can use this to calculate different values. So let's say we're given this triangle and we're asked to calculate angle x and x. Well, how the heck do we do that? First of all, let's solve and complete. We have all these angles, right? And we know that all the angles of A, B, and C add to equal 180 degrees. Knowing this, we can write out 180 degrees minus 60 plus 20 is equal to 100 degrees. So we know that angle x is equal to 100 degrees, and we can put this into our triangle. But we still don't have this x value, and this is where the sine law comes in, because we can use these ratios. For example, here we have sine 60 over 12, it's opposite length. It's important to notice that this angle here is divided by the opposite side length, just like angle x is opposite side length x, and so on and so forth. So we have a ratio sine 60 over 12 is equal to sine 100, because we want to find the side length opposite 100 degrees, so sine 100 divided by x. To solve this, you can use cross multiplication, but I prefer to multiply both sides by x and divide out our sine 60 over 12. I know it's not very nice, but we're left with x is equal to sine 100 divided by sine 60 over 12. And so we find x to equal 13.6 meters. So here I've put in a few values, and I've only given our angle A, side A, and our side B. And the number of values that we have here looks kind of sparse for how confusing our ambiguous case triangle might be. But if we use our sine law, where sine A over side A equals sine B over side B, we can find all the angles that we really need to. So here we have sine 30 over 20 is equal to sine B over 32. So we find theta B to be equal to 53.1 degrees. Now we also know that all triangles, all their angles add up to 180 degrees, so if we go 180 minus 30 plus 53.1 is equal to 96.9 degrees. And so now we have our angle B value, 53.1, our C value right here, 96.9 degrees, and we can also calculate our side C to complete this one triangle. So we write out sine 96.9 over x is equal to sine 30 over 20, and we find that x is equal to 39.7. So now we're left with a triangle that looks like this: 32, 20, 39.7. Here we have 30 degrees, here we have 53.1 degrees, and here we have 96.9 degrees. But because this is an ambiguous case, we have to deal with two triangles. So to do this, I'm going to redraw my triangle in its ambiguous case. So here's my new triangle. As you can see, our original triangle used to look something like this being angle B, and this angle here being angle C. But now we have C prime and B prime. However, our A angle is still 30 degrees, our side A is still 20, our hypotenuse is still 32. The only values that have changed is our side C, our B angle, and our C angle. So if we know that this angle here was 53.1 degrees and this angle was 96.9 degrees, this angle here is a mirror of this angle. And it's important to keep in mind that it's not this part of the triangle that is our C value that completes this triangle here. It's actually a different value that would add up to 180 degrees. So we know that this angle is mirrored, and we know that the total angle here is 180 degrees. But our B prime is not 180 degrees, and it's not 53.1 degrees. It's 180 degrees minus 53.1 degrees, or 126.9 degrees. So we now have our B prime, 126.9. Now we just need to calculate our C prime. We know that all triangles' angles add up to 180 degrees, so we go 180 minus 30 plus 126.9 equals angle C, and we find that angle C is equal to 23.1 degrees. Using this information, we can now calculate side C. So we have our sine 30 over 20 is equal to sine 23.1 over C, and we find that our side C value is equal to 15.7. So cosine law is just an extension of the Pythagorean theorem that we learned a few years ago in high school. And it's basically c squared is equal to a squared plus b squared minus 2ab cos times theta times angle C. So essentially here we have our Pythagorean theorem, and the extension here is 2ab cos and then the angle of C. Now normally angle C here is equal to 1, and these just is equal to 90. Angle C is equal to 90 when we have right angle triangles, and this just kind of eliminates itself out because this is equal to 1, and so all we have to deal with is c squared equals a squared plus b squared. But now that we've taken away that 90-degree angle, we have to add this part of the equation. So how we use the cosine law is we need to have an angle here with an adjacent side with two adjacent sides, and we use it to find the side length opposite that angle that we plug into this formula. So here we plug in 25 to equal angle C, we plug in 14 to equal either A or B, it doesn't matter in this case, and we plug in 12 to equal either A or B. And once we punch this through a calculator, we find it to be 6. And that's how we use the cosine law to find side lengths. But what if we have to find angle C using the cosine law? Well, we can simply rearrange our formula to be cos negative 1 times a squared plus b squared minus c squared over 2ab is equal to angle C. It's important to remember that while either 14 or 12 could be either A or B, 19 always has to be C, because this is the length that is opposite angle C, or its side C. So we have to input it just like that. And once we input it into our formula, we find that angle C is equal to 94 degrees. It's as simple as that to use the cosine law. Just remember to plug in your values correctly and rearrange when you need to, and you should be totally fine.